Hello everyone. Good afternoon. Myself Komal Sanjay Nashte. I am from the Annasaheb Dange College of Engineering and Technology, Ashta, Department of Civil Engineering. My roll call is 469 and I will present here the ISA activity second on the sliding base isolation. So let's we start for the presentation. In this presentation, I discuss with you the following points. The first is the introduction, how sliding base isolation works, benefits of the sliding base isolation, design consideration and limitations of the sliding base isolation, and the conclusion and case study. This is the part of the introduction of the sliding base isolation. Sliding base isolation is a seismic protection technique used in a structural engineering. It involves introducing a sliding mechanism between the building foundation and the ground. The goal is to reduce the transfer of seismic forces to the superstructure, ensuring better safety. In this slide, I will show you the difference between the sliding base isolation building and the without sliding base isolation building. The left side building is without sliding base isolation and the right side building is the with the sliding base isolation. We will watch the video until the end and see the difference between this. The in left side building more vibrations are occur and these vibrations are transferred to the superstructure and there is a chances to collapse the building. And in right side building there is a less vibrations are occur because of this plate is provided in the construction. This plate is resist the movement horizontal movement between the substructure and superstructure because it cannot be uh, transfer the horizontal movement to the top surface of the building. So in this slide, I will show the base isolation lead rubber bearing. The building is connected to the lead rubber bearing which are also attached to the foundation. When an earthquake occurs, the building itself should not be affected, but the lead rubber bearings are affected. The lead absorbs the kinetic energy of the movement of the ground and release it as heat. The rubber is deformed. Here we can see the different types of the pictures. In that figure we can see the how it can be isolated, how base isolation work, and which are the components are used in this. The in between the superstructure and the substructure there is a base isolation bearings are provided and lead plug is provided in between the two rubbers and the tops on the top portion stiffness plate attached attachment plates are provided and the stiffness plates are also there. And when an earthquake occurs the horizontal movement are occur in between the building. Then it can be the sliding buildings can be slide but within the limit, but it can come back to its original position when the movements are uh, minimum. So this is the lead rubber bearing technique. So in this slide I will show the sliding base isolation how it can be actually work. This is the top portion is the superstructure and the bottom portion is the substructure, and in between the substructure and the superstructure sliding base isolation is provided, and this plate is resist the horizontal ground movement, ground shaking movement, and it cannot be passed the movement to the top superstructure. And we will watch the here the video and this is the plates are provided. And that time in the right side we will see the base isolation technique how it can be provided in a building. Now, theoretically, we see the how the base isolation works. The core of the system consists of the isolation bearings, which are strategically placed between the building foundation and the superstructure. These bearings are typically made of materials such as a rubber, lead, or sliding materials like PTEE. When seismic forces are transmitted to the building, the isolation bearings absorb a significant portion of this energy. They deform and slide, allowing the building to move independently from the shaking ground. This is the benefits of the sliding base isolation. Sliding base isolation provides excellent seismic performance, reducing the risk of structural damage. It enhances occupant safety by minimizing the effects of ground shaking and reducing structural response. The technique is adaptable and can be retrofitted to existing structures or incorporated into a new construction. Here we will discuss the design consideration. Types of the isolators. There are the various types of the isolators including elastomeric bearings, sliding bearings and hybrid systems, each suited to different situations. Structural considerations. The building's structural design should accommodate the movement allowed by the isolators, including flexible architectural features and reinforced connections. Types of the sliding base isolation. The first is the frictional pendulum system, second is the sliding plate system, and the third is a roller system. Friction pendulum system utilizes a pendulum with a sliding interface to absorb seismic energy. The second is a sliding plate system, employs a sliding plate or surface between the foundation and the superstructure. Roller system uses cylindrical or spherical rollers to allow relative movement between the foundation and the structure. All the methods have their own limitations. So for this sliding base isolation, there are some also limitations. Sliding base isolation system require regular maintenance and inspection to ensure their continuity functionality. The technique may not be suitable for all types of the soil conditions or in areas with extremely high seismic hazards. Cost considerations can be a challenge as implementing sliding base isolation can increase construction expenses. So this is the last point of the our presentation. That is the conclusion and the case study. Sliding base isolation is an effective seismic protection technique that reduces structural damage and enhances occupant safety. It has been successfully implemented in various structures worldwide, with notable case studies demonstrating its effectiveness. Continued research and innovation will further improve the performance and applicability of sliding base isolation in future. Thank you so much guys for watching this video and we will see you soon in the next video. Bye bye.